that we need to do. And what I would like to do is I'd like to get these quizzes done today in class. So I want to set a timer for 10 minutes. I want to set a timer for 10 minutes, and I want you to pop in to the classroom. I'm sorry. I realized the start date I need to change on the one so that you can take it today. And I want you to go in there and let's just take these right now. Some of you are not getting them done, and then I'm calling you and leaving feedback saying, hey, let's get this quiz taken. I know we've got a lot going on. So what I want to do is I'm going to take the first 10 minutes off the top of class right now, and I want you to take them. You know these quizzes are short, okay? You know these quizzes are super short. Okay, so let's just log in and do them right now, at least one attempt. And then when we are done with those 10 minutes, we're going to go into genetics prep. So I'm setting the timer right now. And we're going to take 10 minutes. There's two. So do one. And if you have time to do the second one, do the second one. Okay. 10.04 and 10.06. We're just going to knock them off at the top of class. So I'm putting 10 minutes on right now. Okay. And we're going to be quiet and get these suckers done. I will make sure that they are available. Let me go peek. Okay. You should be able to see both once you refresh. You should be able to see both once you refresh. I may need to start the time on this one. No. Because I'm just adjusting them right now to today's date at 8 a.m. All right, so everybody should be outside of this window taking the 10.04 quiz and the 10.06 quiz. At least one of those, if not both. We've got a 10-minute countdown going on. Okay, let's go ahead and get those quizzes done for the week out of the way. It's 10.04 and 10.06. Yep, Kylie, we're going to go ahead and get a couple quizzes done at the top of class today. These are review quizzes. So go ahead and pop into the classroom and do the 10.04 and 10.06 quiz. We've got a timer countdown going for 10 minutes. And then we're going to start our review. Awesome. It's 10.04. This one right here, I moved them up to Monday, Tuesday due dates. 10.04 and 10.06. And these are short. 10 minutes. And I've got it set on my phone, so we'll hear it. Let me go look, Emma. All right, Heba, it should, if you refresh, it should show that you can take it now. I don't know why it had you exempted. That was strange. No worries. All right, I'm watching the grade book, and for those of you who are in here to finish your quizzes, so make sure you're in there. Right now, we're taking the first 10 minutes of class to get at least one of these 2 quizzes done. So make sure that's where you're at and what you're doing. All right. My timer just went off. We spent 10 minutes for those of you. Oh, there's Sean. Sorry. I was trying to watch our numbers. We spent the first 10 minutes of class. Good job, guys. Of class working on our. I feel like as we go through the week, it seems like sometimes that's where we end up slacking a little bit, is getting those quizzes done. Then when I have to go in and zero out the grade book, I'm like trying to remind you guys to go in there and take them. But this is just a reminder right now, and you can do this as we transition right here. Make sure you go to your grade book. Please check your grade book. Those zero, guys, a zero weighs down your grade a lot. And I don't have a ton of people not passing, but I have more than I'd want. I want 0 people not passing. And I also want to make sure I don't think that we really shouldn't have less than a C in this class. So if you have anything less than a C, I think you need to go in, make sure your quizzes are all taken, and retake some of those quizzes that you may not have high scores on. Okay? Yes, good. Good. Yes, so and if you want to go ahead and pop in and do those right now, Sean, that's fine too. I really want to prioritize those because I feel like the more we get behind in the spring, that I don't know, as we get close to testing and then I'm out, it just I want to keep you up where you need to be so that no one slides before testing and has anything next to a grade that we don't want. All right. So what is a karyotype? Tell me what this picture right here is. Somebody tell me what we're looking at. What are we looking at right here? That's awesome. Yes, these are chromosomes. All right. These are chromosomes from a cell. So the DNA is unwound and then cut into pieces, and we get to look at the different sections of our DNA. This is what we call a karyotype. These are the sections from each side of your DNA. One of these sides you get from your biological. What? One of these pieces in set 1 you get from your biological mother. And one of these you get from your biological father. Good. So you see, for every organism, you can look at their karyotype, which is just a picture of their DNA chromosomes paired together, all right, with the piece that they got from their father and from their mother. All right. In humans, we have 23 pairs of chromosomes. Our last set, our 23rd pair, is what we call our gender determining, diploid. Our gender determining set. All right, this is what tells us what gender we will be. It gives us our X and Y chromosome. If you are a biological male, your chromosomes will be 1X, 1Y chromosome. If you are a biological female, it will show 2X chromosomes in your karyotype. All right. This is important to know for your state test. Yeah. Hit me with your question, Ireland. Yes. Yep. Every single human, we all have the same amount of pairs. And like every organism is going to have a different amount of pairs. And that's kind of part of an identifier too. Like mice will have a certain amount of pairs of chromosomes. Birds will have a certain amount of in different types of birds, but if that makes sense. So we, as humans, have 23 pairs. She's processing, yes. This is our DNA, right? So that's the double helix that gets wound up and is in the nucleus of our cell. That's our DNA. So if I took one of your cells, and you can actually do this, if I took like one of your cheek cells. Yep, so remember when we have our cells that are in our reproductive cells, right? Our reproductive cells are going to have half the amount of this information. So they start with all of this DNA, okay? And they go through the process of meiosis, right? Yeah, but I'm just talking about your cheek cells. So this is a diploid cell. We know this because there's 23 pairs. If there was only one of each of these pairs, we would know that we're looking at the DNA from a haploid cell because there's only one. Yeah, no, you're doing a great job. You're piecing it all together. Oh, so if I took one of your cheek cells, it would be a diploid cell, and it would have all the DNA in your whole body, like that would represent all of your cells, right? If we took the DNA and we unwound it, and we put an enzyme in there that would break it up by chromosome. This is what it would look like. So if you lost your DNA, does it come back? Is that what you're asking me? So if you have a haploid cell, that would be the only case where you wouldn't have all of these chromosomes. And a haploid cell would be like a sperm cell or an egg cell. And in that case, they didn't lose anything. It was just a process of splitting up your DNA to prepare them for reproduction. And then they gain that other half during reproduction. And that's when then like, so if if you are expecting, you're pregnant, you can go in and take cells from your embryo, and it would be a full picture like this. All your embryo cells are going to be diploid cells that have full sets. So yes, so down here in this 23rd set, this is our 23rd. You have 2 chromosomes that determine it. So as females, we have 2 X chromosomes, okay? As males, they have an X, and then they have a Y. I'll check it out in a little bit, okay? Thank you for showing me. I'm trying to make sure I understand. So males, right? They have an X and a Y chromosome. And that just sends out like the proteins and the hormones or whatever. That's what makes us chemically different. They still have 2 sex chromosomes, sex identifying chromosomes. Same thing with the females. Now, when we go through meiosis, when we have them, you're right. The males can contribute to the offspring. Their sperm cells have either an X chromosome or a Y chromosome to contribute to the baby. As females, we only have X, the variety X, right? Or I think this is our double X. We only have X's to give. So when our DNA splits, we are like, oh, well, we can contribute an X or an X. Does that make sense? That's fine. Yeah, you can use your notes. So if this were a cell and it went through mitosis or meiosis, it would essentially be halved. And we would have two cells. And on these lines, Ireland, this cell would go to that would go to one cell, this would go into another. This is like our spindle fibers in the cell. This would go one way, this would go the other. This would go one way, this would go the other. See how they split them? But this is all like what we're looking at here is a karyotype of any cell in our body except for our sex determining cells. You're thinking that maybe there's multiple of this. Yep. Both male and female will split their chromosomes like that into their sex cells, and that is what gives us traits. Absolutely. Now, males, they make greater amounts of reproductive cells. Is that what you're talking about? Yes. Okay. So they essentially could have greater genetic variety, right? Women are born with all the eggs in their ovaries that they'll ever have, right? But men are constantly making more sex cells. Constantly. So they make a lot more of their reproductive cells than we do. So I guess what would that would increase the amount of meiosis that happens in a male body versus a female body. So yeah, I think I follow you. So technically there would be a greater chance for differentiation in their genetic variety because they're making more. They still only have 23 pairs to choose from. So it's always those 23 sets. It's just rearranging those 23 sets through crossing over in meiosis, if that's what you're talking about. Yep, it's only repeated like because you have one set from mom and one set from dad. And all of our cells in our body keep both of those sets. We need both of those sets because it gives us all of our information. It's like we need the whole cookbook. But when it comes to our reproductive cells, we know those cells are leaving our body. They're not staying here. They only get half because we know that the other half is eventually going to be met to make the whole cookbook. I think we're there now. Does that make sense? I think you're there. Yes. Okay. We'll keep thinking on it. After class, we can come through and clear up any other misunderstanding. All right. So let's look at this. This is a sheep karyotype. All right. This is a sheep karyotype. It has 27 sets of chromosomes. All right. Look, it says through 26, and then we have our sex determining. So this would be our 27th set. It's pointing at a number that says homologous pair. What can we dissect that we know a prefix to? Where can we go ahead and dissect this word at? You have permissions to write on the board. Yeah. All right. We might not remember what homologous means, but we're going to dissect it right here. And we know homo means the same. Okay. So homologous pair, we're looking and saying, something about this pair is the same. So let's read. It says select the 3 correct statements based on information contained in this karyotype. All right, so we're looking for 3 correct statements. So 1, the sheep is male. Is that true or false? The sheep is male. That's true, right? We just talked about how XX indicates a female and XY indicates a male. So we can say, well, we already know one of these is true. This is not, there's no guessing about it. We know XY indicates a male. So that is true. This sheep is a female. True or false? The second choice. Well, if we said this is a male, then it's not both, right? You're biologically one or the other. All right. Down here to the third one. Sheep somatic cells are diploid. Sheep somatic cells are diploid. All right, let's read. This diagram shows the karyotype of a muscle cell. Right, this is a muscle cell from a wild sheep. Yeah, muscle cell tells us it's not reproductive. HAP, HAP means half, right? This is half, but we see that there's 2 chromosomes for each pair. So that tells us that it's not a haploid cell, right? So let's go ahead and cross this one out, which would make this true. Somatic cells are diploid. Somatic cells are any cell in the body that is not a reproductive cell or that is not a haploid cell. So a muscle cell is not a reproductive cell. So we know that that's somatic and muscle is somatic. And we know diploid means there's going to be 2 chromosomes. So that is also true. Let's come down here. Sheep gametes contain 26 chromosomes. Sheep gametes contain 27 chromosomes. What do you think? Which one of those is true? How many chromosomes pairs are there? Yep, 27 is true. Okay. There are 26 and the sex determining, which is also a pair. Yep, so those are our correct answers. Good. Good. Let me peek at the next one, see if we have time. We have like 3 minutes. So this is crossing over. Let's talk about this because we were just talking about this with Ireland's question. All right. So this is what our chromosomes look like in all of our cells except for our reproductive cells. Okay. This is a chromosome from mom and a chromosome from dad. And the way we get genetic variety, which it means like I don't just get half of my body from mom and half of my body I get dad's traits. The way we get a mixing of those traits is because of crossing over. So when they line up on the cell equator, right? This is a cell. When they line up, remember in metaphase at the middle, these chromosomes actually twist around each other. and hug. And then they break apart and exchange genetic information. All right. Otherwise, it would just be like every single one of our haploid cells are the same. There wouldn't be a very much variety between what I look like and what my mom looks like, or my dad looks like. But because of crossing over, I could have my dad's nose shape and my mom's eye shape and a mix of their eye color. Yes. Imagine you wrapped arms and hugged somebody so tight that it just broke off at those points and fused back together. That's exactly what happens in crossing over.
I was watching the TV.
Okay, that's fine.
Oh, the little gremlin stole the show.
She did. Awesome. Does that make sense? Give me a smiley face again with crossing over. This is how we make haploid cells. Haploid cells are cells with half our genetic information, and those only go to one type of cell, and those are our sex cells, our reproductive cells. Right? All of our other cells are called diploid somatic cells. Everyone say diploid somatic. So put diploid plus somatic equal body cells. Right? That they make up your hair cells, they make up your skin cells, your eye cells, your lip cells, your tongue cells, your T cells, your bone cells, your muscle cells, your stomach cells, your intestinal cells, your liver cells, your heart cells, your brain cells. All of those cells and more are the cells that have a full set of DNA. They're called diploid somatic cells. The only type of cell that has half the amount of information, or haploid cells, okay, haploid cells are the cells that are in, so haploid equals half. Put that in chat. Diploid cells do the crossing over during the process of meiosis. Okay? Haploid cells do this during meiosis. And that's the process in which cells duplicate and they divide once, right? And then they divide twice. Meiosis is the process in which we make our sex cells, our haploid cells, right? Because we don't just have haploid cells on hand, we had to make our own haploid cells. So females, we went through the process of meiosis as we were being developed as embryos, as infants, babies, okay? And then those are stored in our body and we don't keep going through the process of meiosis. Men, boys, males, they are constantly reproducing, making reproductive cells. Haploid is half the amount of chromosomes or DNA. Okay. Haploid cells have half the amount of DNA. They're those cells that are like, we only have half of the recipe book. But they're supposed to be like that until they find their other half, right? Diploid have two. They have the full set. Diploid have the full chromosome set. Full set of DNA, which is 2 chromosomes for each pair. Okay. Full set of chromosomes for each pair. I don't know why that is. Hold on. I don't know why that hyperlinked to something. All right. Haploid versus. Why does it keep? I don't even know what that's doing. Why is that doing that? Haploid. We already have. I'm going back to diploid. Diploid is your full set of chromosomes. Right? Two chromosomes for each pair. There we go. Now it's not hyperlinking. Okay. Haploid, a cell with half the amount of DNA that it's supposed to have, one chromosome for every pair. A diploid has all the DNA, all the chromosomes for every pair, and it is associated with somatic cells.
Mommy.
Hold on one second, Rennie Roo.
Oh, Ren.
Somebody needs a banana. All right, we are late.
Sorry.
All right. If you have questions, stick around.
Yay.
And if not, finish your quizzes today, Rennie Step. Finish your quizzes today. And we will see you tomorrow morning.
Goodbye.
Have a great day, guys.
Have a good day.
They're all saying bye, Ren. See you guys. Ren, please stop. Thank you, baby. They said bye, Ren. Bye. Arya says get better. Oh, isn't that so sweet? Thank you. Have a great day.
Have a great day.
Thanks, Kylie. We'll see you tomorrow.
See you tomorrow.